I'm presenting on phytoremediation of cyanide. We all know that land and water are actually precious natural resources which agricultural sustainability depends on, and the quality of human being generally depends on. And the progress of science and technology and the progress of industrialization has encouraged the use of certain chemicals which actually contaminates the environment. One good example of this chemical is cyanide. What is cyanide? Cyanide is a group of compounds that is formed when one atom of carbon is connected, is linked with a triple bond with nitrogen. This cyanide can be natural or artificial. What do I mean by natural or artificial? Natural in what sense? Natural means that some plants have the ability to produce this cyanide, that is, they are cyanogenic plants, and the artificial one comes from the man-made, that is, we can actually synthesize this chemical. This chemical has various uses in the industry, in the production of plastics, in the production of fertilizer, and in the production of herbicide and plastics. So, majority of the cyanide majorly comes from the anthropogenic activity, that is, activities that involve that are man-made activity, and these are the sources of cyanide into the environment from the mining industry, from agrochemicals, that is the fertilizer, and this one is majorly common in our environment these days because most of this comes from the cassava processing wastewaters, and this one is from the plastic industry. We all know this cyanide is very toxic, it's highly toxic. So scientists around the world has find a means of reducing this contaminant in our environment by using various methods, which are mechanical. They've used chemical method, mechanical method, but they on the long run they discovered that these methods are not cost effective, they are not environmentally friendly, and they are costly. So recently there is a new kind of techniques that is used in remediating, that is reducing these toxicants in the environment, which is phytoremediation. And what do I mean by this phytoremediation? Phytoremediation is just a technique in which plants, especially green plants, are used in restoring back a contaminated site into their normal state. As I said earlier on, phytoremediation mainly uses the inherent ability of plants to actually convert this toxic compound into non-toxic compound. I'm using cyanide as a good example of toxicant. So in using phytoremediation, you need to go to do a kind of screening that you select species of plants that are capable of detoxifying this compound. And there are three factors you must take note in selecting your plant, which are the uptake ability, the transport, and the metabolism of the plant. These are the good examples of plants that have actually been identified to metabolize cyanide very well. And various techniques of phytoremediation, we have phytoextraction, phytostabilization, phytovolatilization, and phytodegradation. These are the pictorial representation of each techniques. But majorly for this my presentation, I will focus more on phytodegradation. This is the ability of the plant to use the natural resources the natural substance within the plants to actually convert this toxic compound back to a less or non-toxic compound. Phytodegradation is also known as phytotransformation, that is the conversion of this pollutant into a non-toxic. For cyanide, which is my case study, which I'm using as a case study, two major enzymes have been identified to partake in this mechanism, which are cyanamide synthase and sulfur transferase enzymes. These are the two pathways that play a crucial role in. So I would like to go to the first one, which is cyanamide synthase. The cyanamide synthase actually use amino acid to convert with the cyanide here by converting it to alpha cyanamide, and another enzyme will now act on it to convert it to asparagine, which is an amino acid. The second pathway is sulfur transferase pathway. In this pathway, we have two enzymes, which is rhodanase and 3-metacapto sulfur transferase. We actually call it 3-MST. What this one does is it actually converts the cyanide by taking the thiosulfate, by attacking the thiosulfate. This mechanism of enzyme is actually a ping-pong mechanism, that is a double displacement mechanism. Phytoremediation and genetic engineering. These are the limitations that one can actually encounter during the selection of plants. So with the method of recombinant DNA, one can actually improve on this area. To my conclusion, phytoremediation are powerful tools available for historically contaminated sites, and cyanide contaminated site can regain its environmental value when cultivated for phytoremediation purpose, thus reducing the potential threats from cyanide.
Thank you. Any comments? Questions?
The use of cyanide is a poison. To us, it's a poison. We know that. And it can affect you.
Yes, sir. It actually affects the mitochondria because the electron transport chain actually occurs within the mitochondria by the transfer of electron within complexes. This cyanide actually is an uncoupler, that is, it actually inhibits complex 4.
When did you read this about chemistry?
Sir?
When did you read this about chemistry? Complex 4.
Yes, sir.
I don't know about that.
Sorry, sir.
Complex 4.
That's
I know there is complex 4.
cytochrome C oxidase.
My own problem. Go to the next slide. Cyanide is a nitrile anorganic compound. Is it as simple as that?
No, that's the reason why I don't want the PowerPoint to be worded. I actually define that it's a group of chemicals that is actually formed when one atom of carbon is connected to.
Are all cyanides organic? That's my question.
No.
So that is faulty. See? And then,
Sir, they can be organic since they contain
I'm
carbon.
not saying they are not. My question is, are all cyanides organic? That's what I'm saying. For example, is potassium cyanide organic? Is sodium cyanide organic?
No.
Well, we have demethylated from the other forms that are organic. So, any other comments, please?
Is there any limitation on advantage in using phytoremediation?
It actually has some limitation. That was the reason why I actually combined this thing with recombinant DNA. Because when you use a certain plant on a site, you are possibly able to. It is possible you encounter some problem, which is how long will this plant takes. How long will it take this plant to take up the contaminants from the soil? That's one. Is this plant has a strong root to actually tap into the depth of this soil to remove the toxicants?
Question, answer
Limitations to these methods. I found it to determine the concentration that the plant are actually metabolized on this transfer. What I say.
You are using plants to remediate. Now, the plant itself, after absorbing these toxic substances, will they become safe too? They are still in the environment, they are still around. So, can we actually say there is any benefit?
Yes, sir. The benefit in the first pathway I showed was a kind of scenario where the cyanide is converted to an amino acid
By the plant?
Yes.
Okay.
Yeah. Can you define phytoremediation without using the word remediation?
without using the word remediate.
Because you are using the word remediation, that means you are still making use of that term.
Phytoremediation is the techniques used in restoring the environmental value of soil. Sorry, sir. Let me. Is a kind of techniques that is used in restoring back a polluted site.
All right. Thank you. Next presenter.